We're now moving on to graphs that intersect. So what's going to happen here is they will ask you to find the solution when the different graphs intersect, or they'll phrase them differently throughout the questions. But if we'll look at a couple examples of what they could ask you. So one of them will say, find the solution. Well, this is the example on page 376 in the Heinemann book. It says, find the plot the graph of y equals 3x minus 2. Find the coordinates of the point of intersection where this line meets the line y equals 3. So we're looking at this equation, y equals 3x minus 2, and the equation y equals 3, and they want to know the points where they intersect. So we'll do the same thing that we've done in the past. We'll substitute values in. I just use -1, 0, and 1 because those are pretty straightforward values to plug in. So if I say -3, -1 times 3 is -3. This is always going to be -2. That's an easy thing to fill in. -3 minus 2 gives me -5. If I do 0 times 3 is 0, minus 2. 3 minus 2 is 1. So the coordinates we're looking at here are going to be -1, -5, 0, -2, and 1, 1. Okay, so when we do this, you want to make sure that you use a ruler to combine these points, especially when we're looking at lines that intersect, because we'll need exact measurements here. My ruler is not quite big enough. I'm going to move it up so I can extend my line even further. So we've graphed the one line now. So then they want to know, where does that line intersect with the line y equals 3? So I go and draw my line y equals 3. So we go to where y is 3, which is right at that point there. Let's use the other expo. And again, I want to use a ruler to draw the line where y equals 3. We know that's going to be both positive and negative. And we draw it on like that. This is going to be my y equals 3. And we know there's arrows on it because it kind of keeps going after that, those points as well. Okay, so they want to know, where do these two lines intersect? Well, we can see very obviously where these lines intersect, and that's going to be right here at this point. So to figure out the coordinates, we know already that one coordinate, the y coordinate, because it hits right there at 3. To find the other one, we want to go straight down to the axis and figure out what this point is. This point is 1.5 right there, so I'm going to probably say that's 1.65, 1.7. So the coordinate would be 1.63. And the book is telling you here plus or minus, see, 1.4. I'm sorry, I'm looking at the wrong thing, 1.63. They said exactly the right coordinate as we did. So again, you want to space out your x and y axis enough so that you'll actually be able to use it to solve a question that they're asking you. So this is going to be the solution. The solution to where they intersect is the coordinate 1.63. That's one way of asking a question like this. Another way that they can ask you questions like this are going to involve quadratic functions or other kind of functions. So in the next example, on example 9 on page 377, they say to draw the graph of the quadratic function y equals 2x squared minus 2x minus 4 for the x values between -2 and +4. So I've given us a table again. This is going to be the easiest way to do it. So if we look at this, -2 squared is going to give us a +4. -2 times -2 is a +4. I'm going to go ahead and fill in this line so I don't make a mistake and do it incorrectly. These are all going to be -4. Okay, so we have 4 plus 4 is 8, minus 4 is +4. -1 squared is 1. -2 times -1 is a +2. 2 and 1 give me 3, minus 4 is negative 1. 0 squared is 0, negative 2 times 0 is 0, minus 4 is negative 4. 1 squared is 1, negative 2 times 1 is negative 2. This is the same, so 1 minus 2 is negative 1. Negative 1 minus 4 is negative 5. 2 squared is 4. Negative 2 times positive 2 is a negative 4. Minus 4 again. So this is going to be 0 minus negative 4 is negative 4. 3 squared is 9. 3 times negative 2 is negative 6. So we have 9 minus 6 is 3. Minus 4 is negative 1. 4 squared is 16. 4 times negative 2 is negative 8. 16 minus 8 is 8. 8 minus 4 is 4. Alright, so we want to go ahead and plot this on the graph. So we have the coordinates negative 2, 4. Oops. I'll extend this a little bit here. Okay, so we have negative 2, 4 right there. We have negative 1, negative 1 right there. 0, negative 4. 1, negative 5. 2, negative 4. 3, negative 1. And 4, positive 4. Alright, so you can see this is a quadratic. We're going to do our best to combine all these points into a smooth curve. That. This side was a little lacking. I'll see if I can trace it so you see it a little bit better. Okay, so they've asked us to plot that, and they've said to use the graph to solve the equation x squared minus 2x minus 4 equals 0. If it says equals 0, that means when my y coordinates are 0. So I go over and I look to see my answers. My answers are going to be right here. These are the solutions where it passes the x-axis. So if I look at this, my solutions, so this would be like some space here. So what we're looking for, not erasing it easily. Okay, so what we're looking for in A is the solution when y is 0. So the way they'll tell it to you is they'll put equals 0 and put the equation on the other side. So for A, we have the coordinates. We can look to see where it intersects. Again, I counted by 0.5, so I'm going to call that 0.4. Negative 1.4 is one solution, and what's the other solution I'm looking at is about 3.1. So again, that's the x coordinates. There is a little bit of grace they give you on this because it's not exact, but that's why you have to do the best that you can to draw the best line through all of the points, because you will need it to figure out some solutions. And let's see what the book has given us as answers. They've said negative 1.2 and 3.2. So my answers are within, are close enough to be correct. You can be within 0.1 or 0.2 to still have a correct answer, but do the best you can. There's not a huge range that they give you. So that was A. The second thing they're asking is to use the graph to solve the equation x squared, so they'll give it to you like this, x squared minus 2x minus 4, that was our original equation, and now they're saying equals 2x minus 5. So what that means is, if it's equal, then the points are equal. Well, when are 2 points equal on two different lines? When they intersect. So what we have to do is graph the second line and see where they intersect. So again, we want to graph 2x minus 5. So if we want, we can draw another table. If not, we can recall a different way of drawing a linear equation is going to be to begin with your y-intercept. In this case, my y-intercept is negative 5. I'm going to have to extend my graph a little bit again. Negative 5. So here is negative 5. And my slope or my gradient is 2. So we know it's the same thing as 2 over 1. And we know we go rise over run for the slope. So we want to go up 2, 1, 2, and over 1. Or we can also, to find the next point, go down 2 and to the left 1, right there. I'm going to move my 7 over a little bit so we can see. So we have another line. All we need are 3 points to make a line. And I'm going to again take my ruler and draw a line through my points. It looks like my squares are slightly not squares because they won't exactly go through. In your notebooks you won't have that problem. They should be exact. So here we have the line 2x minus 5. So again, we're looking at where they intersect. Where do they intersect? They intersect at this point right there. Now we can also continue drawing my line up. And let's see. Make sure it's again a little bit easier on your page because you will have smaller distances to do this with. Okay. Okay, so we have another point where it intersects. Right here. Okay, so we want to know what are the coordinates to these points. So if we look at this, we again have to draw a line. We'll do this with blue so we can see it a little bit more obviously. Up to the x-axis, and on this one we want to go down to, which is a little convenient on this one, to the x-axis. So what are the coordinates of the intersection? Well, we have here, this looks like it's point, again I counted by 0.5, so maybe we'll say 0.3, 0.3, and then my y right here is, if we draw over to my axis, it's really maybe negative 0.6, 4.6, and then the other one would be, if I draw my line here, that looks about 3.6 and 4. So again, we have to do the best we can and make sure that our lines are as straight as possible. So it's really important that you have a ruler, and we can check here and see what the book is giving for the solutions. They're saying the solutions are 0.3, which we had, and 3.7. So we had 3.6, so that was good. So they were asking for the x solutions for that. We gave the coordinates of the whole thing, that's not incorrect, but if they ask for the solution, it would be the x values. The last thing that they're going to ask on this one, this isn't actually 2, it's b, although the same thing, the second thing they're asking. The next thing they're asking, if you look on the bottom of 377, they say use your graph to find the positive solutions of the equation x squared minus x minus 2 equals 0. Now, when we look at this, we have to see, well, what's the difference between what we have found, this equation here, and what they're giving to us here? And the difference is going to be the next line that we have to draw. So, if we look at this, x squared minus x minus 2, we have this equation to begin with, x squared minus 2x minus 4. What are we missing in between these two equations? That's what we're looking for here. So what are we missing? Well, we have x squared, okay, that's both there. So the next thing we want to see is we're missing another x, right? So we need another x. So that's going to be what's on the other side of this, negative x. Okay, and what are we missing here? We have a 2. We're missing a negative 2 to give us the negative 4. So we need another x and another 2. So the equation that we want to draw now is going to be this one, negative x minus 2. So when we look at this, again, we're looking back and saying this was the original equation, this is the new equation they're giving us here. How do we get from this one to this one? Well, we need a second x, negative x, that's my negative x, and we need an additional negative 2 to give us this negative 4. So negative x minus 2. So we're going to plot this point now. Again, I'm going to use the same way. I'm going to start with my y-intercept. That's -2. So I go over here and I draw my point at -2. My slope in this case is -1. So that could be a -1 over 1, or it could be 1 over -1. It really doesn't make a difference, but we do know that it's going to be a downward slope to my line. So if we say it's -1, 1, that means we would go from -2 or the y-intercept down 1 here, and then to the right 1 this way. Or we can go up 1 and to the left 1. So those are the 3 points that we need to make a line, and then we will connect these points. Same way as we've done with the other ones. And then asking us for its intersection with a quadratic equation. So these points of intersection are going to be this point and this point. So when we look at this, we could say, and they ask specifically on this one for the point, use the graph to find the positive solution of the equation. So when we look at this, we know this worked out very conveniently. Again, we're looking at the x points here. It's 2 and -1. So the answer for C would be x equals 2. I went from this point up to my x-axis, and -1. So if they're asking for just the positive, then it's going to be 2. Now this is a little bit more confusing because they ask you a lot of questions and they don't put it in words as much as equations. This, for example, the x squared minus x minus 2 equals 0. It's not a totally new equation. It has to be related to the original equation that they gave you. And that's why you have to look back and see, how do I get from this one back to my original equation? We need another -x and we need another -2. That's going to be the more complicated way of looking at it. So be sure that that's something that you understand. And if not, then please go ahead and ask.